In this lesson, you'll learn how to solve problems with scientific notation. So let's get started. So what is scientific notation? Scientific notation is an easy way to write very large or very small numbers. It's used in science and engineering to talk about quantities that are really big or really small. It's written in the form a times 10 to the nth power, where a is a number greater than or equal to 1 and less than 10, and n is an integer, meaning it's a positive or negative number. For example, 300,000 can be rewritten as 3 times 10 to the 5th power, and the decimal 0.00025 can be rewritten as 2.5 times 10 to the negative 4th power. Now follow along as I solve this problem. Which of the following numbers is written in scientific notation? Well, remember, scientific notation is written in the form a times 10 to the nth power, where a is a number greater than or equal to 1 and less than 10, and n is an integer. So looking at my options, it's either going to be B or D. And remember that the a, or coefficient in front, has to be greater than or equal to 1 and less than 10. And here, 0.3 is less than 1, so B cannot be correct. And D works because 5 is greater than or equal to 1 and less than 10, and it has negative 4 as the exponent, which is an integer. So my answer is D. Now it's your turn to practice. Pause the video and solve the problem. And when you found your answer, click play. Which of the following numbers is written in scientific notation? Here you need to find the number that's written in the format a times 10 to the nth power, where a is greater than or equal to 1 and less than 10. 16 is greater than 10, so that's not going to work. C does not work. And for D, 0.025 is less than 1, so that's not going to work. Here, 7.2 is greater than or equal to 1 and less than 10. And 5 is an integer. So the answer is B. Now let's talk about how to convert numbers to scientific notation. To convert a number to scientific notation, first move the decimal point until there is only one non-zero digit to the left of the decimal point. Then count the number of places moved. This number determines the exponent. For example, to convert the number 4,500,000 to scientific notation, first put the decimal to the right of the ones place, and then move the decimal point to the left, so the resulting number is greater than or equal to 1 but less than 10. So I'll move the decimal point 1, 2, 3, 4, 5, 6, which means the coefficient is now 4.5 times 10 to the 6th power, since I moved it over 6 places to the left, which makes sense because every time you move the decimal point 1 place to the left, you're making the number 10 times smaller. So to balance that out, the base of 10 gets a positive exponent, the same number of decimal places that you moved the point to the left. To convert the decimal 0.0000375 to scientific notation, you need to move the decimal point to the right so that the number is greater than or equal to 1 but less than 10. So in this case, I need to move the decimal point 1, 2, 3, 4, 5, 6. 6 places to the right, which means the resulting coefficient will be 3.75 times 10 to the negative 6th power, which makes sense because every time you move the decimal point 1 place to the right, you're increasing the value of the number by 10. So the base of 10 gets a negative exponent with that number of places you move the decimal point to the right, so that the value of the number stays the same. Now follow along as I solve this problem. Convert 650,000 to scientific notation. So I'll start by writing out the number, and then adding a decimal point to the right of the ones place. And then I need to move the decimal so the resulting number becomes greater than or equal to 1 but less than 10. So in this case, I'll move the decimal point 1, 2, 3, 4, 5 units to the left, which means the resulting coefficient will be 6.5 times 10, and in this case, I move the decimal point 5 units to the left, so the exponent will be positive 5, which makes sense, because when you move a decimal to the left, you are decreasing the number by a factor of 10. So to keep the value unchanged, you need to increase the exponent in the positive direction. So the answer is 6.5 times 10 to the 5th power. Now it's your turn to practice. Pause the video and convert 9,750,000 to scientific notation. And when you found your answer, click play. Start by writing out the number 9,750,000. And then add a decimal to the right of the ones place. Then move the decimal 1, 2, 3, 4, 5, 6 places to the left, which gives you a coefficient of 9.75 times 10 to the 6th power, because you moved the decimal point 6 places to the left. Hey, it's Nicholas, creator of Mathemy, and if you like this video and want to take your math skills to the next level, check out my online course, Pre-Algebra Made Easy. Whether you're preparing for algebra, geometry, or a standardized test like the GED, ASVAB, or GRE, this course is for you. Dive into interactive videos where you'll shadow me through problems, then take the reins to practice solo. Worried about making mistakes? Don't be. I'll walk you through each solution, making sure you understand every step. But it doesn't stop there. Quizzes, practice activities, and detailed answer keys will solidify your understanding. Cap it off with section tests and an end-of-course exam to showcase your new skills. Mastering pre-algebra is the key to future success in math and beyond. Click on the link in the description below to enroll now and start your journey to math mastery. I'll see you there.